Hello and welcome. I'm George Crump, Chief Marketing Officer with VergeIO. Thanks for joining us today. Today we are going to go through I think, a very interesting conversation about some testing that our friends over at StorageReview did, combining several different technologies that I think you'll find interesting. And we have a cast of characters, emphasis on the characters. But like I said, I'm George Crump with VergeIO. Also joining us is Brian Beeler, President of StorageReview. Wave at the folks. And then Kevin O'Brien, Lab Director with StorageReview. There he is. He's actually in the lab. That's not a virtual background, so he could like touch something or something like that. And then also is Scott Wernz, Solutions Architect with Solidigm. Scott, thanks for joining us. And then on my side, I've got, to keep me honest, I've got Larry Ludlow. He is a principal engineer at VergeIO, and he was helping the StorageReview guys with some of the testing. So before we jump into kind of the details, Brian and Kevin, why don't you start with sort of background on StorageReview, what you guys do, all that kind of good stuff.
Well, I should say that you've got Kevin in the lab. He's authentically there to touch and show you the gear that we were testing with. But you've assembled here a lot of really technical people. So even on the Solidigm people, this is not marketing. These are real engineering, hands-on kind of guys. So I encourage anyone to ask questions or follow up with George after this if you want to get more technical about any of these solutions. But fundamentally, we love to see, touch, feel things. And Verge is obviously a software-defined solution. So we worked with leading partners, including Solidigm, Cool IT. We've got a liquid cooling angle on this, Gigabyte on the server. We've got so much to get into. I'm really excited about it. But yeah, Kevin's in the lab. We can show you the systems we're working on, talk about how it all came together. But this is an amazing panel of highly technical people, great guests, and I think we'll have a lot of fun with it today.
Great. And I do want to mention that somebody just put a thing in there that they couldn't see everybody else, but I think I fixed that, so we should be good to go now. There is a Q&A. You've got a whole bunch of people that technically are qualified to answer questions. So as stuff comes up, we'll one of us will chime in and answer there, and where we can, we'll try to take some of the things live. Scott, do you want to give the folks a quick background on Solidigm?
Sure. Solidigm is one of the industry-leading solid-state storage vendors. We have a heritage of over 50 years of solid-state technology with a combination of the Intel NAND group and SK Hynix NAND group. We were formed a couple of years ago as a spin-up and offshoot, and we have actually currently have the largest SSD on the market, which I believe we're using in this demonstration. And we have a lot of really good cutting-edge technologies. I've been in this industry for over 30 years, and I'm super excited to be here, excited to be a part of this, and I'm excited about VergeIO's technologies.
Thanks. And then for our part, we are a software-defined infrastructure product. Probably most people know us as a potential alternative to VMware. Hopefully you'll see some things that will make you think that that's a good idea with us. There's two core differences. One's a business and one's a technology. The technology part is our software is the entire infrastructure capabilities integrated into a single code base. So roughly, you get the equivalent of ESXi, vCenter, vSAN, vCloud Director, and NSX in a single piece of code. That's about 400,000 lines of code for all of that. Why that matters is, A, when you buy the product, you get everything. You may not own NSX today, but I bet you there's some capabilities of it that you would like to have, especially if you didn't have to pay an arm and a leg for it. We provide that to you. The second thing is incredibly efficient code. So you'll tend to see us get better performance in almost every situation than our competition. You'll see some examples of that today. And even on, running in the storage review lab, this was cutting edge stuff. We run on 5, 6, 7-year-old servers and get incredibly good performance. We do what we call in-place replacements all the time with VMware, and customers will report back that they're seeing 25, 30% performance improvements on the exact same hardware. So that's one of our big values. The business side is we went through all this effort to simplify infrastructure. We didn't want to have a complex pricing model. And so we license by the physical server, not by number of cores, not by number of CPUs, not by amount of capacity, RAM, any other thing that people come up with to figure out how to charge for things. So all you got to do is count how many physical servers you have, and that's how many licenses you need. And like I said, it's totally inclusive and everything's in there. So Kevin, I want to just kind of turn it over to you. Let's not keep the people waiting. Can you kind of give us an idea of the testing process, what you have there, show some of the things that you have to show and things like that?
Yeah. So we had a lot of fun building the VergeIO platform. In our lab, we have a lot of really high-end hardware to play with. So when VergeIO reached out on mentioning, hey, we'd like to build a project around our environment in some hardware that you have in your lab, I was like, okay, well, we have a lot of flash, we have a lot of high-speed networking, we have really high-end CPU and compute architecture. So we leveraged a quad node gigabyte platform, which is liquid cooled with CoolIT cold plates. These are AMD EPYC Bergamo CPUs. We used a Mellanox 100 gig, or NVIDIA now, 100 gig backend network for connectivity between the nodes, as well as a bunch of Solidigm flash for this cluster. So the platform that we have, it's 24 bays, so 6 drives per node. And we got to leverage the 5620 drives for metadata, the P5520 drives for pretty good read-write mixture of storage, as well as the incredibly dense 61.44 terabyte P5336 SSDs for a massive footprint of QLC storage. So this cluster gave us, I want to say it was around probably a quarter petabyte of storage in total in a 2U footprint, 8 CPUs, a lot of performance to throw at different workloads we put on. We saw some really incredible results. Read and write performance took a lot of benefit of the 100 gig backend networking, but we saw performance across our QLC and SSD, or QLC and TLC testing, where the write performance on the TLC tier was in excess of almost 7 gig a second. QLC SSDs around 5 gig a second. And this is where VergeIO is really unique. VMware, even to this day, doesn't really support QLC SSDs. So being able to take advantage of those really dense drives, you can fit a lot of capacity into a small footprint. And QLC drives, as we've seen, really provide you with a strong mix of read-write performance. I know a lot of people are concerned about endurance, but we've thrown a lot of these drives over time, and we've seen expected lifetimes, even in heavy write scenarios, of 5 to 10 years. Like they have a lot to offer. So being able to put this into a converged infrastructure really excites us.
Yeah, that's a good point too about the varying drives and the flexibility that VergeIO enables. I mean, at a high level, I think most people aren't running 4-node 2U clusters liquid cooled. So we took, George, your example of 5 or 7-year-old hardware that you're refreshing with VergeOS. I sort of cringed a little bit thinking about what we did in our lab, but it does show the scale of anything from a little bit older to leading edge technology. And as data centers consider all the environmental impact, AI servers, all these new workloads, liquid's going to be a bigger deal. So we just sort of skipped ahead in the playbook a little bit to show you how that worked. But Kevin's right, too, in that the ability to use higher write endurance drives for the metadata, higher performance TLC drives for maybe the tier 0, tier 1 workloads, and the QLC drives to still have great read performance for workloads that aren't as write heavy, but offer amazing capacity. I mean, that blend of what you can do is unmatched, I think, at this point in the hypervisor world. When you mix feature set ability to adopt all these different technologies like QLC. And I think from the Solidigm perspective, I mean, QLC has been a really foundational element of the company. And I know you're talking about shipping 61.44s today, but you're showing off 122s. I mean, the trajectory for flash density is amazing. I'm sure, Scott, you've got some thoughts on that.
Yeah, we definitely have seen a huge demand for these large terabyte, 61 terabyte drives. Obviously, the hyperscalers and anybody that's doing anything with AI needs to have these giant pools of data. And we're getting great performance, super low latency, great ROI. And we have a lot of customers actually replacing their hard drives with these large QLC drives because they're much more power efficient. You get much more performance, and you can replace dozens of spinning disks with a single QLC drive. So.
Well, it's interesting too, and George, I'd like your thought on this, because when you talk about your licensing model, what we did with that 4-node cluster was absolutely astounding. And since you're licensing on node, man, I'm afraid that with all this power that we might be impacting your business if we start giving people all these drives and cores that AMD has, and you're not nickeling and diming on all the different feature sets and capabilities. It's kind of amazing. But are you worried that we're making it harder for you to sell this thing?
No, I don't. I mean, I think if you look at it externally, that could be a concern. But the company the difference is I don't have 10 salespeople in every zip code like other companies do, right? And so we've designed the company for that eventuality, right?
Mm-hmm.
So and we've the last year, I don't know if you guys heard, but Broadcom bought VMware, and it kind of upset the market a little bit. Almost from the moment that announcement became official, I mean, we were growing pretty quickly before then, but our sales went up 400%, and it stayed relatively consistent. There was that 1 month where they weren't giving out quotes, but that's a whole different story. But generally speaking, it's that, and it's really easy for any vendor to say, "Oh, the product's really stable and blah blah blah," that kind of stuff. To me, we report metrics every week into the team, and one of the metrics is our customer satisfaction team. And the one thing that I always pay attention to is open tickets, right? If you can, it's no big deal. Somebody calls you, you can solve the problem, you close the ticket, that's fine. It's the open tickets that are the problem, because that generally says you got a bug if you can't close it, right? That open ticket count from, let's say, October, really, this is right before the announcement happened, till today has been remarkably consistent, even though we've seen a huge increase in the number of inbound calls because we're onboarding so many customers right now. And so, if you look at the total tickets, it's way up because obviously, early days, you're always going to call for questions and things like that. But if you look at the stuff that gets stuck, there's been no change in that. And so that's a long way to answer. The company is designed to be, if you will, as efficient as the software itself, right? We obviously we're scaling, we're adding people, but we don't have to do it at the same pace that that other companies do just because of the stability of the solution.
Well, I think there's two important things there that are somewhat related to the work we're doing. Is one, obviously, you can't avoid the new rates that VMware is charging.
Right.
We're talking to so many customers, especially SLED, state local education. I mean, those guys are on tight budgets, on fixed budgets, and now they're having to deal with the reality of, oh my gosh, our renewal just went up 10x. And that's not hyperbolic, that we're seeing those quotes.
Yes.
And that's troubling. When you look at the world of what's out there, Kevin's done a lot of work on this too, I'm sure can speak to it. But when you look at the world of what's out there aren't that many great choices. And I think we got kind of lazy as enterprise customers of just accepting VMware and vSphere as the de facto OS of choice, right, for our organization. Right. And as these organizations are out there looking for other things, you've got choices. You got Microsoft, you've got some open source things, but it's not polished, it's not refined. And the support that's one thing that you were just mentioning that I think is super critical. We didn't engage with your support apparatus because we had a direct line into your technologist, which is the best of all support. But support and being operational, especially with something that's new, is a fundamental concern of why organizations might be slow to change. So I'm glad you highlighted that. But the other is usability. And there's always that concern of, oh, I'm going to go do something new. I'm going to have to relearn everything. Kevin went into this dry. And Kevin, maybe you can talk about interface and some of your experience with managing not just the storage, but VMs, and we did migration. Hit some of those high points, because I think that usability I thought it was very strong.
Yeah, it was a very familiar experience. As we've worked with a lot of different hypervisors, you go from a vSphere environment over to Hyper-V or Azure, and there is a big learning curve on how things are approached. VergeIO is very similar in look and feel to what you're used to experiencing on the vSphere side, and obviously there will be branding differences. There will be areas where menus will be a little different, but it didn't take a lot of work to just dive in and like, okay, well, here are my VMs. I've either migrated them over, created new ones, how to adjust them, increase storage capacity, or even things like moving around between different tiers. Like that, I mean, obviously it's a nice platform with trying to work around those areas, but it's really easy to go in. Like, I love not looking at instruction manuals when I jump into projects. It didn't take a lot of work to really become proficient in using it.
Yeah, talk more about the migration, because I think that's a primary concern too, is how do I get my stuff from wherever it is to something like this if I deploy a VergeIO cluster.
Yeah, we used the elements that was built into the VergeIO cluster to draw out VMs from our VMware environment. So if you're worried about having to use an intermediary piece of software, it's already built in to draw those things out.
Yeah, and if I can, so it's interesting when you go around telling people you have this single piece of code, and then all of a sudden now you have to write an importer for a very specific piece of software. It becomes a bit of a development challenge, right? And so, but what we did is very clever, is VMware has a very well documented backup API set, right? We just added backup code, VMware backup code, into our code. So it gives you an idea, number one, of how much control we have over our code and how well we know it. So we added this capability. So when you log us into vCenter, vCenter thinks we're a backup product. Now, we don't position ourselves, obviously, as a VMware backup product, but by doing that, it gives us everything because it thinks we're a backup product. And so all of those VMs will come over, and Kevin, I'm sure you noticed this, but it's a two-phase process. We essentially do fundamentally a backup. And then once we rest that backup, you can selectively go in and import those VMs into, and basically what you're doing is converting them into VergeOS VMs. The power of this functionality is we also support VMware's change block tracking, right? So you can have all these, let's say I just got off the phone this morning with a customer in the UK who had 1,000 VMs. Well, what they can do is move, back up all those 1,000 VMs. And then most people aren't going to convert 1,000 VMs all at once, turn off their VMware cluster and say, boom, I'm done, right? You're going to do some testing and things like that. Well, they can test 10. While they're doing that testing, everything else stays updated in the background because of change block tracking. Once they approve those 10, they can do one more sync, bring them into production. The value in that is your cutover time now is measured in less than a minute typically. And now you can also, the next 10 you're going to start working on, they're already up to date and you can start working on them, right? And so, and if something goes wrong in the process, because we have these multiple steps, you have multiple points to go back to start over if something does go wrong.
Yeah, in our lab, we explore a lot of ideas, and having an out just in case something does happen is always a top priority, because when things can go bad, sometimes they do, and you have to be able to recover from that. You don't really want to be like, oh crap, well, things gone now. Like, that's never really an answer you'd want to have. So it's nice to have those stages to back up from.
It works really well. Good.
Yeah, I mean, and I think that's important. And then when we were architecting this solution with the performance tier and what we would view as the QLC tier. Some might think of it as an archive tier. But Kevin highlighted some of the performance early on. We also did a major boot storm with 1,000 VMs all spinning at once, and that executed flawlessly on both tiers of storage. I think one thing that's really important that we shouldn't undersell is the flexibility of the VergeOS platform to work with anything. So like I said, with QLC in this case, you can't do that currently on a lot of other hypervisors. And when we think about what Solidigm has done with those 61.44 terabyte drives, we had some early days of people being concerned over endurance. That's the first FUD element, right? Is QLC will never make it. Well, I mean, there are many iterations into it. And we have, some of you guys may not know, we're the world record holder of the pi computation. So 3.14, blah, blah, blah. We're out to 202 trillion digits on that. We hold no one's close. Google was the closest at 100 trillion. And that only works because of the Solidigm QLC drives. And even obliterating those things for months and months and months on end with extreme writes, we did a back of the napkin math on endurance and still think they have a 10-year lifespan. I'm sure, Scott, you've got some maybe better data than ours, but the QLC performance has been really quite great for most workloads, and the endurance is there too, even though I know you guys don't market it as an endurance heavy drive.
Yeah, so we really pride ourselves on having drives that are very consistent with their performance and have very low latency. And the thought process that a lot of people still have, SSDs have been around for, over a decade now, and people still have that drive write per day thought process. And, remember these drives first came out, they were 64, 100, 120 gigabytes. And you did have to be concerned about drive writes per day. When you're looking at drives that are 8, 16, 32, 60 terabyte drives, and you have multiples of these in the system, the odds of you actually doing a full drive write a day on a drive is just crazy. And these drives are already over provisioned. We market it as a 61.44. It's a 64 terabyte drive. But it's over provisioned, so we have plenty of capacity for wear leveling across the device. So I think people have to get out of that mindset of drive writes per day and start thinking of petabytes or even exabytes written over the life of the drive. And so we offer a 5-year warranty on these drives, and we guarantee consistent performance over that lifetime as well. So our failure rates are way lower than industry standards. And we have our customers rave about and really like the performance and the durability of our devices.
Yeah, and if I can chime in on that, the other thing that's nice about our software is that it's designed in such a way that it perfectly places segments distributed evenly across all the drives in the environment, right? And so you'll never have a situation where you have a hot drive or even a hot spot, because the software mathematically takes care of all that for you. So the combination of the two, I would say, you've got a pretty good chance of things lasting a long time. I'll tell you, Kevin, you mentioned about use cases. One of the use cases that Scott and I were talking about just before the start of the session, we have this capability that we call IO Guardian in the software. It's called the backup and repair server. In fact, I want to next time, Brian, I want to have Kevin just start breaking a bunch of stuff and show everything working.
That can be done.
It's a job he was made for, right? Yeah. So think of IO Guardian as, this is the way I've been describing it lately. I think it works. It's a parity server for the cluster in the same way you have a parity drive for a RAID 5 or a RAID 6 group. And so this is a server, it's on the same network, but it's not necessarily part of the same cluster. And what it can do is stand in, not become a host, but provide data back into the production. And so let's say you had an environment where we had some of these drives and for some reason you did have 2 of them fail, or 3 of them fail, or 4 of them fail. In real time, the IO Guardian server will supply data back into the production environment so that nothing crashes, right? So it's if 30 minutes is instant recovery by the backup software guys, then this is real-time recovery because there's nothing you have to do. You don't have to run to your backup software, anything. Also, because deduplication is integrated into that core code, everything understands all the segments. And so when we refresh the IO Guardian server, we do that about 4 times an hour. The only thing we already pre-planned what data is going there because we've already know what the unique segments that were written in the last hour are. And so we just update it. And so your window of exposure in a worst case scenario is 15 minutes and everything happens in real time. So servers don't crash and things like that. To take this to an extreme, I had a customer that had 4 servers in a colo and he was a smaller environment. He was working late one night, left for the day, well, actually late into the morning and left. And usually at 2 o'clock in the morning, you tend to make mistakes. If you're an athlete, it really gets bad. If you're an IT guy, you just forget to lock your cage. So he forgot to lock his cage. Somebody else with gear in that thing, I guess, came in the next morning, thought it would be a really good idea to teach this person a lesson and ejected all the drives from 3 of the 4 servers. Why he just didn't do all 4, I have no idea. Just he was mean. And so obviously, we start getting alerts. He starts getting alerts. But fortunately for him, the IO Guardian server was in another cage locked. And so it started supplying, it's what amounted to almost 80% of the data now started to come off of the IO Guardian server. None of the VMs crashed and the users never even knew it happened. Me being who I am said, hey, let's do a webinar together. And he said, no, we're not doing that ever. So, but that gives you an idea of the extreme. And the whole point of that story is that works well if the drives inside that server are fast, especially from a read perspective, because we don't really care about writes. Well, guess what's fast from a read perspective and very affordable and very dense? The QLC drive. So they're a perfect complement to IO Guardian.
If I can make a little comment, in a previous life I was backup guy, so having to know having an RPO and an RTO. An RPO of 15 minutes is like unheard of, and an RTO of under days or under hours is unheard of too, right? So that's an absolutely great selling point and a really great feature of your product.
Yeah, we should probably have a polling question. Who on the line was formerly a backup guy? Because that's usually the first job you hand off.
Yeah, everybody has that, I think, at one point.
Yeah. So we got a couple of hands going up. So there was a question about comparing this to OpenShift. I'll let you guys chime in, but I think it ties into what Kevin was talking about, that in some cases when you make this shift, it's dramatically different from a terminology and use and everything perspective. What are your guys' thoughts on that?
I mean, at a high level, I would say that I think there's great potential there, but ease of adoption is still a concern. And part of the question I think anyone's got to consider when looking at a hypervisor or an alternative to existing hypervisors is what's the lift to get from 0 to operational. And in our case, I stood up the cluster. I don't know, Kevin, in a few hours total, or maybe even less minutes. I mean, it was very, very quick. Plug it in and install the ISO, and that was kind of it, right?
Yeah, and we also did some kind of unusual activity with, hey, we want to add in a tier midway, and we just started ejecting drives and carefully went through that process. Didn't take it offline, didn't have to reconfigure it. Nothing that was on the cluster went away, and it has that flexibility to really do whatever you need to do, and you're able to do it in a way that it doesn't destroy itself, where you can't say that about all the different hypervisor solutions that we've used. There are quite a few where once you have it set up, if you make any dramatic changes, you're refoundationing that platform to do any dramatic changes. This one, if you want to go a different direction midway through your production cycle, you can do that, and there's some safeguards to make that happen, but you have that opportunity.
Well, yeah, that's exactly right. We didn't start with the QLC drives in the system, and halfway through the project, I was like, wait a minute, we've got 4 more of those drives just sitting around, just toss them in. And VergeOS is like, cool, toss them in. And so we created this tier. And the fun thing about it is those 4 drives are what, a quarter petabyte, roughly, before any data reduction at all. And that's another cool thing is when you think about data reduction layered on top of this capacity, the effective capacity of what we build in 2 RACU is quite
Think of, like,
astonishing.
industry standard like 4:1, we're at a petabyte of storage in a TU footprint.
With 4 drives. I mean, just if obviously there'll be some efficiencies that are there, but yeah, it's really amazing what those drives enable. One other thing too, that as we talk about resiliency, that I think is important, that comes up a lot, and maybe Kevin, you can talk through this, is the VergeOS gets regular updates. Maybe I don't know, George, what your cadence is, but we saw at least maybe 1 pop up during our testing. And I think it was pretty much a click and go, and it sort of bounced around and did its updates. But Kevin, talk about the update process, because that whole life cycle management thing is important to a lot of customers.
Yeah, the update manager that's on the VergeOS cluster, you have it pull for an update. You can do automatic updates online, or you could have a manual file you put in, but it handles that update process in a graceful manner. So it's not like, hey, you click go and it updates all 4 nodes at the same time. It'll do a rolling cycle. So the VMs that can be migrated around will move around, and it's able to do that in place without really any workloads seeing any negative impacts.
So I've got the we captured some video of the 1,000 VM boot. So I'm gonna share that, and Larry's gonna kind of take me through it, because honestly I'm a little nervous because I haven't watched it yet, so I don't know what's gonna happen. I'm assuming there's 1,000 VMs and they all boot at some level. And Kevin, Larry's might be having some mic issues, so if he does, I'm gonna point to you to jump in. So no pressure, but just so you know.
I think I'm good.
All right. Oh, yep, we can hear you. So very
All right.
good. All right. So
Yeah, so what you're not going to see here is we have some limits in our UI. So we only allow so many operations per second. So I basically did some scripting on the back end to do this using our API and bypass that, and instantly just said, hey, I want these 1,000 VMs to boot, and I want them to boot now.
and so
Typical Monday 9 a.m., right?
Yeah.
So this would be, that's on the screen now, is basically just the 1,000 VMs that you created via the API. Is that right?
Yep. So I spun up, I basically cloned a VM, 1,000 clones of it. I'm pretty sure when you play this, you'll see me scroll through a couple of times to show that, yeah, they're all here.
Yeah, I don't think we did a hand count, but I'm pretty sure that they were all there. Very, very many of them. And the time to complete there was pretty close to right now.
Yeah, I think the important thing to point out here too, right, is, a lot of times when we do benchmarking like this, right, we'll use like tiny Linux, we'll give them, a core and like 512 gigs of RAM and, a 512 megabyte drive. And these are full on 10 gig drives, 2 cores and 4 gigs of RAM. So they're full blown VMs.
That's part of the fun thing with the servers we chose. We worked with AMD on those CPUs, and the one thing AMD will give you is a lot of cores in those epic platforms. Kevin, I don't recall which CPUs we used there, but we had a ton of cores in this cluster, didn't we?
Yeah, those were the AMD EPYC 9554. So each of the 8 CPUs is 64 cores or 128 threads. So there was a lot of horsepower behind this.
We had a lot of system resources available to these guys, and a massive storage footprint and the liquid cooling loop. I think we covered almost every technology thing we could, except George, one thing we didn't have time to get into is, I don't want to go heavy in AI here, but GPU support is a relevant question. I know you guys you probably have customers using GPUs. So can you talk about that a little bit?
Yeah. So first of all, short answer is we virtualize GPUs. You need and I always forget the name of it, whatever the NVIDIA software is that allows for the virtualization of GPUs, but what we allow, Grid, it's something, Larry, you
MIG. Well, MIG was part of it, and then they've got some other things coming along, the multi-instance GPU.
Yeah. And so, but we support all that. You can slice it up, and you can assign it to, we just actually just brought out straight pass through as well. So all of that's supported. The other thing we're working on, and the folks that are on the line are sworn to secrecy, but is we do have built into the product a capability called the recipe engine, which is essentially VM templates on steroids. You can deploy complete workloads with multiple VMs and connections and all those sort of things that you might want to do. We're working on basically being able to deploy a complete AI workload with a mouse click, right? So basically it'll load the LLM, it'll load all the stuff, it'll do all the things you need to do. And then, you feed it your knowledge base, and now you've got a chatbot local, right? So those are sort of the things that we're kind of working on as we build out the product.
Well, we're seeing that need too, George, with enterprises wanting to embrace RAGs and have some intelligence against their data, but also for very good reason, reluctant to put that in a public model that who knows what happens to that data. It's not protected, all sorts of compliance issues and concerns there. So yeah, I think anything you can do to help customers do that in-house and just kind of start the AI journey. Early on with AI, I had a lot of frustrations over some of the gatekeeping that was going on. A lot of solutions were designed for huge companies like right. X and Meta and that sort of thing. But we all know hundreds of organizations, thousands, that with a little bit of GPU and a little bit of assistance on how to get operational there, that could make foundational changes to their business models. And an internal RAG may be the best place to start. You don't need a lot of GPU. You get to take advantage of your data in new and creative ways that most organizations have never even conceived of. So to be able to have something like that in the cluster would be pretty amazing. Oh, and I did see the question because I know I was saying, are we making your licensing model worse by putting so much power in these nodes? But someone was quick to point out that the amount of cores that we are running would be self-destructive with the licensing scheme at VMware. We have 8 physical CPUs in this cluster, which would translate, I think, if I remember right, to 16 CPU licenses.
Well, yeah, and if we went for the 96 or 128 core, I mean, you could get up to a 32 CPU license schema for a 4-node platform on
for 1.2U for 1.2U chassis. Yeah, that's expensive.
Well, we run into situations on daily where the customer is paying more for their VM, especially with the new licensing model. They're paying more for their license than they are for the actual physical hardware they're running on it. And we as guys in the industry know how to explain why that's theoretically okay, but try to relay that to somebody that's only kind of loosely in IT and explain why the thing that you can't even see is twice the price of the thing you can go touch and feel. It's hard to, and you look at folks like Scott and Solidigm, right? If you're charging on capacity, that 64 terabyte drive gets really expensive really fast, right? And as the VMware licensing model confuses me a bit, but as I understand it, there's a surcharge on vSAN once you get over a certain capacity, right? So that starts to really add up. So
licensing model shouldn't be punitive if an organization's enjoying your product and wants to do more with it. I mean, I think as a marketer, that would bring you great joy. That's what that was always the story with HCI in general. And that's how we're set up here, is that I'm going to throw a couple workloads on it. Oh, that kind of worked better than I thought it might. And then they just keep piling it on. Right. And with this capacity that we've got with these 5336 SSDs, I mean, it's wild. A quarter petabyte physically raw in 4 drives is just somewhat magical to think about all the stuff that unlocks on top of with your OS on top. I mean, it's quite remarkable.
I should say,
and you had asked me earlier about the model. We're so because it comes up like, are you guys going to change it? And I'm like, yes. Once we have 80% of the market, we're going to get you all. No, but
get there first.
Yeah, exactly. No, but we're so embracing it that on Tuesday we announced we've had this capability that we call IO optimized. There's some machine learning and what I would describe specifically as narrow AI, meaning not a large language model, built into the product. And so it does a lot of things that abstracts us further from the hardware. Well, one of the things we've added just now is the ability to shrink an environment, right? So as far as I know, we're the first software vendor saying, yep, we want you to hand in some of your licenses, right? And so because we've had this come up where we had a customer that was a VMware customer, they had 16 servers. They realized the trick of our licensing. They went out and bought I think it was 10 quad processor boxes, and we set it up so that when you do that, you click one button and the software essentially shrinks. It automatically moves everything where it needs to be. It repositions. Because you think about it, when you're not only are you decommissioning a group of servers, you're also decommissioning it to fewer targets. And so that's actually kind of complex. And so we do that all automatically in the software. You come back a little bit later and it says, okay, you can turn off those servers now.
Yeah,
so that's built into the product.
Yeah, not even with a migration like that too, but you just think of like hardware refresh cycles as we get denser and denser compute. We just had a customer this past week where we moved them onto the beta just for that, purpose. They had, I think, a 6-node cluster. They replaced it with a 4-node cluster because they got better density, and it made it nice and smooth for us.
Well, George, let me ask you a question. I know this is your webinar, but we put together, I mean, you basically said, StorageReview, here's your mission. We're going to layer some licenses, go build something cool. And we did. we built an amazing cluster. That flexibility, though, you didn't give us a list of parts and say, build it, but only with XYZ servers or drives or whatever. And I'm sure there's an HCL somewhere that Kevin certainly did not check before deploying our cluster. But what is the core go-to-market? So for anyone listening to this is like, oh, this might be pretty cool to check out. What is the model for someone to say, check out VergeOS and then to go deploy it? How does that work with the flexibility that you enable on the hardware side?
Yeah, so the first thing, there is no HCL. Again, it goes to that IO optimized capability. We've got a lot of intelligence built into that. Depending on which SE I have on the phone, sometimes I'll have a bunch of Intel NUCs in the background running as different clusters. Other guys have full build out things. So it varies wildly. What I typically recommend, and I'll put a link in the webinar when I'm done talking here, but what I typically recommend is we have this hands-on lab available. It's an instance that we essentially own, but you're in full control. There's a little script thing that kind of tells you what to do, so you can kind of go through the different labs and everything. And that's a great way to kind of get familiar with the product. There's 3 of them. I'm kind of sort of trying to get a 4th one done, but you can go through those. And once you do that, you probably feel pretty comfortable. At that point, we're happy to give you a download copy of the software. It'll run for 30 days, but we can extend it. And the only, Larry, I might tap on you to make sure I get the numbers right, but we do need 2 physical servers. Memory is 64 gig. Is that right, Larry?
So 16 gig plus workloads. And, legitimately, if it's just a POC or home lab, a single node is fine. If you want to really be able to test the vSAN, though, you'll need 2 nodes.
So that's how that works. And, then from there, you're kind of off to the races. So it's pretty straightforward from there. And, guys like Larry are there to help. You had mentioned support earlier. Larry, because I got it wrong yesterday, what's our SLA on support right now on Sev1?
Don't remember what our SLA is, but I know what our average initial touch time is, under 5 minutes on every ticket.
Yeah.
Whether it's Sev1 or not. Yeah. So very good. And, the customer I was speaking with that we're actually doing a write-up on, he was amazed because on any issue, we had him if it was a big issue, we had him on a Zoom call within like 10 to 15 minutes. So
Well, I do love the bring your own hardware, and that gets talked about sometimes and executed sort of questionably from time to time from our experience. So yeah, the fact that we took a bunch of stuff that probably you guys, maybe the Knicks you had seen, but probably not a lot of customers running this more exotic amalgamation that we put together, and we didn't have any trouble with anything. It just sort of popped. And I think when we think about where these clusters are going to go into effect, whether it's at the edge in a core data center, the hardware differences there are dramatic, and the workload differences can be as well. All this stuff just works, and let us be flexible with the way we wanted to deploy it with the big drives, the liquid loop, all the stuff we wanted to do. No problem. And so to hear you running on NUCs, we didn't go that small in our experiment, but to know that you could is kind of neat. I mean, it's a lot of flexibility.
Yeah. Well, maybe the next test we should have you like pick the oldest servers in the lab and try to get it running on that.
Unfortunately, those are still pretty modern. We give away all of our old stuff to our Discord community. So one of the fun things you mentioned Home Lab a second ago, Larry. One of the fun things we like to do is when we're done with stuff, try to enable someone else to go figure out how to do things, to learn pfSense or learn these things. And so we're regularly giving away gear, and I make Kevin do it pretty religiously, because if not, it'll be floor to ceiling in every room of our office with hardware that we never use. So I'd rather.
I was going to say, I'll take some of the liquid cool stuff.
Brian.
I know you just got a bunch of new servers to play with, and I'm sure which is another fun thing, because Solidym's actually, I was out in their new lab or updated lab outside Sacramento just a few weeks ago, and these guys are pushing some really cool stuff. So I'm sure you'll need to get your own Verge OS cluster set up out there so you can get hands-on with this stuff.
Absolutely. And one of the things I wanted to mention, I talked to George about this. So, you don't, when you're moving to VergeIO, you don't need a greenfield hardware deployment, right? And as we were just talking about, it doesn't need to be the latest, greatest brand new hardware. You can repurpose maybe something that's a couple generations old, especially for your proof of concept, and test on that, and reutilize hardware maybe when you make a transition. But yeah, that's a really great feature, and the ease of migration and importing the VMs is super impressive. So it's an exciting product.
Yeah, I think we do what I call two types of upgrades. One is kind of an in place where we're going to literally replace the existing VMware hardware, and so you start us, you clear off one node, start us there, and we just sort of swap everything in over the course of an afternoon or so. And then probably about the other half of the time, as guys bought 2 or 3 new servers, they put us on that. We pull everything over and then convert the old, if the customer wants to, convert the old servers to nodes as well. And again, we support a mixed environment, so it's really no problem for us to do that.
I do want to.
George, you should put the labs link that you were talking about, or details on that. It looks like there's some interest in the chat to check that out. So that would be a great one to share. And I know too, our audience would love to maybe pick up on that too, and see what this looks like.
Feel free to share it. There's I just put it in there for everybody. There's no sales call required. Basically what's going to happen is you'll fill out a form. It'll come to me. I set you up with the lab, and you're off to the races. So the only thing I'll tell you, it's a little weird, is we provision everything on the fly. So when you first log in and create your lab account, it takes about 4 minutes for all the hardware to get provisioned for you, and then you're off. So just go get a cup of coffee or something, and it'll be ready to go.
Hey, look, if the marketing guy can deploy the labs, it can't be that bad.
Yeah. I wrote all 3 of them with Larry's help on one and Bob's help on another. But yeah, we do. The first lab is a VMware migration. So you actually are in charge of a VMware cluster and a Verge cluster, and you move VMs over. So you get to see that firsthand. The second one, frankly, is my personal favorite. It's our snapshot labs. So it goes through all of our different snapshot capabilities. One of the cool capabilities of that is you can, let's say you had a VM, it's running, everything's great, your snapshot's an hour old, somebody, fat fingers a file or something. You don't have to recover the whole VM just to get one file back. Well, what this will do is you can mount a VM's a snapshot as a drive to the production VM, and then it's just a simple copy command to get it back. So that lab takes you through that whole process. And I purposely did it in Linux because if you're a Windows guy, I figured, hey, if I can do it in Linux, how easy is it going to be in Windows? So that was my strategy there. And then the final one is we haven't actually talked about today, integrated into the product is multi-tenancy. So we can create tenants. It obviously is popular with infrastructure as a service providers, but even in business, we see people deploying these to do things like, segment out mission critical workloads from, business critical workloads from, say, user workloads. And by doing that, you're essentially firewalling all of these different workloads from each other so that they're protected and things like that.
Yeah.
All right. We probably ought to land the plane. We got busy chatting and everything. So we're here if you guys got any more questions. I think we've gotten to everything. I appreciate everybody attending, guys. First of all, I appreciate your efforts and attending the webinar today.
Hey, thanks for having us. We had a lot of fun with the hardware and the software combo and all the toys we get to play with here. So as you know, we're very hands-on, and to be able to layer you guys on top was a great joy.
Awesome. Great. Well, good stuff, guys. Everybody have a great afternoon. The link to the lab is in the chat still. So if you click on it now, or you might lose it. So anyways, thank you, everybody. Have a great day.
Thank you.